I'm Anil Kumar. Welcome to my series on functions. In this video, we'll talk about two test questions which are being shared by one of our subscribers. So let me thank Mr. Dylan for sharing these questions, and I wish he could share the complete test papers with us. I'm very sure that many of us are going to benefit a lot from the solution of these questions. A function f of x equals to 4 square root of 3x plus 5 plus 1 has been transformed into the graph of g of x equals to minus 3 square root of minus 2x minus 6 minus 4. State the mapping rule and write the transformations that would transform f of x into g of x. You can actually pause the video, answer the question, and then look into my suggestions. Now, it's kind of important to understand that we are talking about a square root function. So let's begin with the parent function, which is square root of x. And from this parent function, we get both the functions f of x and g of x. So we have f of x here, which is 4 square root of 3x plus 5. This is kind of merged, so let me give some space here, plus 1, right? So if you look into this particular transformation, then how do the coordinate points map? So if we have a coordinate point xy here, then how will this xy map into this particular function? Well, you should actually take 3 common. So if I take 3 common, so we get 4 square root of 3 x plus 5 over 3, right? Plus 1. And clearly, the mapping is that horizontally it has been compressed by 1/3, so it is 1/3 of x, and then shifted 5 by 3 to left, minus 5 over 3. So that is what happens to the x points if we compare with square root of x function. As far as the y points are concerned, they get multiplied by 4 and then translated 1 unit up. So for f of x, that becomes the transformation. Now let's look into g of x. G of x is given to us as minus 3 square root of minus 2x minus 6 minus 4. Now we should factor this. So we get minus 2x plus 3 within square root minus 4. So as far as g of x coordinates are concerned, you will notice that any point xy on the parent function will actually move to the x values will be now minus half horizontally compressed and reflected on the y-axis, and then 3 units to left, minus 3 I should write, comma, and y coordinates get multiplied by minus 3 and minus 4, move 4 units down. So that becomes the transformation. Now since we have a common base, we can now compare these two. Does it make sense to you? So first and foremost is to relate both the functions with the parent function and then talk about transformation. Is that point clear? Okay. Now let's begin with the vertical and horizontal part separately. So let's talk about horizontal first. So that means the x values, okay? So we are trying to relate these two things. One is 1 over 3x minus 5 over 3, and we are doing this relation with minus half x minus 3. Now clearly you can see that horizontally, if I have to equate this, I have to multiply this by minus 3 over 2, right? So minus 3 over 2 is my mapping from f of x to g of x. Is that clear to you, right? So let me write down the mapping. Let's say this is the end of this. So we'll write down the mapping. So as far as the horizontal is concerned, we'll multiply by minus 3 over 2, right? 3 over 2 of x. So this will map these two. Is that clear to you? Correct? Now, translation part. Since we multiplied this by minus 3 over 2, let's actually do it. So we do minus 3 over 2 times 1/3 of x minus 5 over 3. That gives us what? Well, when you open, you do get minus half x here, but this becomes plus 3 and 3 cancel, and you get 5 over 2. So, if you look at it, the transformation horizontally is minus 3, right? So we have minus 3 minus 5 over 2. That is to say, 2 common denominator, minus 6 minus 5, or minus 11 over 2. Do you see that part? So this is minus 11 over 2. So we get horizontal transformation totally. Perfect. Now, let's talk about vertical. Okay, so we'll talk about vertical. That means comparing the y values. Okay, so we look into these, which is 4y plus 1 as compared to minus 3y minus 4. So if you compare 4y with minus 3y, you know clearly it has been multiplied by minus 3 over 4. So we get here minus 3 over 4 of the y value. Correct? So applying the strategy, we'll multiply minus 3 over 4 with 4y plus 1. So what we get? We get here minus 3y, and this is minus 3 over 4. Now we'll compare translation, vertical translation. It should be how much? Minus 4 minus of minus 3 over 4. Perfect. Which is equal to minus 4 plus 3 over 4. 4 being common denominator, minus 16 minus 3, plus 3. So that gives us minus 13 over 4. So this should be minus 13 over 4. Is that clear to you? So that becomes the mapping. That becomes the mapping. So we have right answer right there. So let me write down the answer once again. So the mapping from f of x to g of x will be in this form. So g of x now will be, let's put it in a box. I'm just copying this. Minus 3 over 2x minus 11 over 2 x values. The y values minus 3 over 4 y minus 13 over 4. Is that clear to you? And this is the method to be adopted. Once again, whenever you have to relate to transformed functions, go back to the parent function and relate both of them with the parent function. Once you get this relation, it is kind of simpler to get the final result. Otherwise, it is extremely difficult. Now with that suggestion, I'll take one more example. You can actually pause the video in the beginning of next example, solve on the basis of what we have done here, and I hope you get that. Using mapping rules, describe how the graph of f of x equals to minus 0.6 divided by 2x minus 2 plus 3 can be transformed into the graph of g of x, which is equal to 1 over 3x plus 9 minus 11. Indeed, a very difficult question. So let us try to understand the method. We are given two functions, f of x as equal to minus 0.6 divided by 2x minus 2 plus 3. Now, minus 0.5, think like this, can be written as 6 over 10, which is 3 over 5, right? So you could actually write this as minus 3 over 5. Now in the denominator, you can take 2 common, you should, so that you can describe the transformations properly. So that is how you could write your function f of x. Perfect. Now, g of x. G of x is given to us as 1 over 3x plus 9 minus 11. So here we can write 3 common in the denominator, x plus 3 minus 11. Clear? That is the first step. Now we need to see how are they related, or how do f of x get transformed to g of x. As you can see, both of them are transformed from the parent function. Let's call that parent function as p of x equal to 1 over x. So the transformation is basically from this function. Is that clear to you? So to relate them, it is a good idea to see how they are related with the parent function. So that is kind of critical to understand. Once we do this relation, we have something in common, then we could actually write the mapping diagram. Otherwise, it could be very tricky. So I hope you understand this part, right? So let's look into this flow. If the parent function is the reciprocal function 1 over x, how do we get f of x? Well, and how do the points get transformed? Now here clearly, we see that horizontally it has been compressed by a factor of half, so the coordinates in this case could be written as half of x, and then 1 unit it has been translated right. So that means increased by 1. So that is how the x values have changed as compared to the parent function. Y values have been multiplied by minus 3 over 5 and then moved 3 units up. So with reference to the parent function, that becomes the transformation. Clear? On the other hand, with reference to the parent function, the transformation is the x values horizontally compressed by a factor of 3 and then moved 3 units left, that is minus 3. The y values, y as such, nothing happens vertically, minus 11. So that is the transformation of g of x from the parent function 1 over x, right? So one step. The next step is to relate these two. Is that clear? So we'll start with the multiplication part first. So let me begin with these two factors. So what we see here is that the horizontal compression, here it is half x, here it is 1 by 3x. How do we get this result? Well, clearly, I have to multiply by 2 over 3 to get this result, right? So the transformation, if I am saying that my coordinate points, let me write here on the side the coordinate points, and then we'll actually work out in details. So if I am saying that on this side my coordinate point is x and y, this is on f of x, right? So this is on f of x. Then on g, what has happened here is, as far as this is concerned, horizontally I have to multiply by 2 over 3 to get the result. Is that clear to you? Right? So this point here should be 2 over 3 times x. Is it comparing these two values, right? Now let's get into the vertical transformation. Now in the case of vertical transformation, okay, let me write a comma here. In the case of vertical transformation, what is happening here is that y value is minus 3 by 5 and here it is just y. That means we have to multiply this by minus 5 over 3, right? So what we get here is minus 5 over 3 of the y values. Is that clear to you? So as far as the compressions and stretches and compressions are related to horizontal and vertical are concerned, you get your points. Now, let's talk about translations, right? Okay, so let's talk about translation, horizontal translation first. We have already multiplied this by 2 over 3, correct? So what I'm trying to say here is that we have 2 over 3 times half of x plus 1. So if you open this, you really get 1 over 3x plus 2 over 3. Now this has to be compared with 1 over 3x minus 3. Do you see that? So let me write here. This we are comparing with 1 over 3x minus 3. From here I'm writing this. Is that clear to you? So these are the two comparisons which we are making. So horizontally, what is the difference? Well, it is minus 3 minus 2 over 3, right? So what we get here is, relating these two, we get minus 3 minus 2 over 3 as the result, which is equal to minus 9 minus 2 over 3, or I can write minus 11 over 3. So this is minus 11 over 3. So do you understand how we got the translation part? So we equated the stretches same and then compared the translations, and we got our result. Is that clear to you? Perfect. Now we are going to do exactly similar thing for the vertical. So in the vertical part, you see we have minus 3 over 5y plus 3 here. We multiplied by minus 5 over 3. So if I multiply by minus 5 over 3, this term, which is minus 3 over 5y plus 3, what do I get? I actually get y minus 5, 3 and 3 cancel, minus 5. So that is what we get. And what do we have here? We have y minus 11. So if you link these two, what is the vertical translation? Well, the vertical translation is minus 11 minus of minus 5, which is equal to minus 6. So here we get minus 6. Is that clear to you? That is how we could actually relate the mapping of the two functions. Clear? Perfect? So that is our answer. So in our case, the question was, using mapping rules, describe how this graph can be transformed into that graph. Now you have to describe. So horizontally, it is getting stretched by a factor of 2 over 3, right? Because you're getting multiplying it, right? So first part is horizontally stretched by a factor of 2 over 3, right? And then translate left, because this is minus, right? We should write vertical first. Reflection on, this is vertical, x-axis. Then vertically stretched, I'm writing in short form, by factor of 5 over 3, and then we'll write translations. So it is minus, means we can write 11 over 3 left and 6 down. So that becomes the transformations. So that is how the function f of x will be transformed to yield g of x. Does make sense to you? So I hope that clearly explains how you could map and then write the transformations. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.